Okay, hey, hold on a sec. So I'm gonna record this so we just have a good record of this. So if you don't mind, I'm just recording.
Yeah, go for it.
Okay, go ahead.
So,
Ideas on a CNC torch table. Go
yeah,
ahead.
CNCs in general. So, one of the big control problem is the ground loops and everything that's going on in these machines, which usually, if you don't have electronics done right, presents quite a lot of problems.
Uh-huh.
So, I'm trying to rethink this, that we should, at least in our design, we're having motors and controllers, or at least stepper drivers. We want to have them integrated in the trolleys themselves, not in a separate box
Uh-huh.
or at the end of the construction. Which means that we
That's the
need to make
current way that you're. Hold on, just for clarity. So integration into the trolleys themselves via wireless is what you're considering currently, or with wires?
just considering how to do it. So one option is normal RF wireless, which might not work well in such environments where you have spindles, frequency controlled motors, plasma cutters, and all of that. I don't want to really go there with wireless and try to make it very reliable. So optics is another problem. Now, one option is using uh, infrared links, such as similar to the ones that are TV remotes, but just higher bandwidth, just doing it free space, which should work well to some extent, but also because we're going into high dust environments and stuff like that, might not always be very reliable. So the latest idea is we should try to reuse toslink optical cables for the communication in this case. So they're plastical optical fibers, um, which you can buy anywhere you use for audio video systems normally, and we could easily build add-ons that support this. So
Yeah,
you
and
could kind of extend conventional controller boards with the optical link instead of the cable between the board and the stepper driver. So
op there's optical fibers. So you said wired optical fibers or wireless optical?
wired optical fibers.
Wired optical. And the
Yeah.
issues on noise for the electronics there is, are you concerned about that?
Well, there are no electronics issues then because you run fiber into potentially, a metal enclosure and you've got no problems there.
Um, and any of the noise from the plasma cutter?
Yeah, noise from plasma cutter can't couple into the optical fiber, so you're kind of safe.
Noise can't couple into the optical fiber, but as far as the board, that's much less to worry about because there's just much less wiring on the board itself. So in general,
No,
when
but
there's
you have a board on the trolley,
yeah,
so you've got the stepper motor, stepper driver, and some board which couples optical fiber to that board.
right.
It means that um, that piece can be inside a metal box, actually.
When you say metal box, you mean that's RF shielded?
Yeah, yeah.
Mm-hmm. And if it were not RF shielded, there would be some issues from the board picking up noise.
Not necessarily.
Okay. Yeah, I'm into.
This is something we would need to find out experimentally.
And what's the advantage of the optical? Is the lack of noise going through optical, right?
Yeah, like you've got no
That
ground
sounds.
electric loops problems.
Yeah, I mean, to me right now that sounds like a great idea. How technically more complicated is it? Is it?
Um, we just need to develop the interface between the optical and stepper driver controller, which is not too complicated. Like not many people have done something like that, but stuff is more or less readily available to do it. So,
Uh, and
few
you're a,
people.
and you're on the forefront of that kind of innovation with your optical link, right? So you're the guy to do this.
Yeah. Well, there's not much optical involved here. You just buy the transceiver, which is
Yeah.
a connector at the same time. So just need to put the microcontroller on it and just do some communication magic, but not a lot actually. So
Yeah. Yeah. Yeah.
um,
That.
we'll definitely
How
look into this
confident are
later this
you
summer.
that you can work this out in a time period of what is it? You're talking about a couple of weeks or 4 weeks or what kind of time do you think it will take you to develop this?
Stage.
I'm sorry, you cut out. Can you say that again?
Um, I Yeah, we can get to the prototype stage in the next month or two with this, so it shouldn't be too big of a problem.
Okay, and as far as so, does that mean that is that so that means a working cutting machine at that time, or so
No,
basically?
we can have a working machine before that,
Uh-huh. But you're gonna
and we'll see what kind of problems due to the noise we may observe in this case.
I see. So as the next step after that, you're looking at this. So you're
Yeah,
hoping that
we can have some prototype working by that time already.
uh-huh. What kind of results are you hoping for from the prototype if you have that working? If you're assuming that it's not gonna be robust enough, that you might get troubles here and there.
Well, we might need to spend quite some extra effort trying to make it reliable and do electronics properly, grounding and all that stuff.
Mm-hmm.
So
Mm-hmm.
we don't get too many problems.
Right.
Uh, and like if we manage to solve this with optics, then maybe we can use high frequency ignition plasma, which could mean that maybe you don't even need a Z-axis later on. So
Um.
that's something to consider.
Wait. You wouldn't need the Z-axis for what reason? Why wouldn't you need it?
Plasma cutter, because you could use the high frequency arc, which you don't need contact start for it.
No, but you do understand that that's not acceptable for large work pieces with that warp.
Yeah, that's definitely true. But just thinking of simplifying in a like basic stage if need be.
Oh, so you're saying simplification for small work pieces if need be?
Yeah, like you don't need an extra axis.
Yeah,
Uh,
yeah. You don't need it. It's not at that point. It's not critical. When we cut out the wheel mounting plates for the tractors a few years ago, there was no Z height control on that. We just set the
yeah,
height, and for small work pieces, it's perfectly fine. The quality
yeah,
goes down just a little bit because if it's not at the right height, you get a little edge, less clean edges, but it works.
yeah. So
Yeah.
that's actually the point. If,
Okay.
then we can have a very simple version of it.
Yeah. That's doable for certain small pieces. It wouldn't do for like cuttings, for example, 1/8 inch steel for the hopper on a brick press, because
True.
that can
Yeah,
warp and yeah. Okay.
yeah. So this is something I'd really like to explore because no one seems to have done it so far, and it appears to be an okay idea.
Which part? The optical
The
coupling?
optical
Yeah.
communication.
No, that's. I think that would be great. That would definitely get you potential advantages on the wiring, which otherwise has to be shielded.
Yeah. Like wiring is not a simple thing otherwise, and you need optical couplers and stuff like this. And here you build them inherently just by
Yeah,
building the link.
I like it. So the other things are that I just wanted to. Yeah. Any more information on this or? Yeah, I like it.
No, that's pretty much it for now. Like costs will be, I don't know, like few dollars per axis connection, so not much.
A few dollars for the transceiver.
No, for like
Like
the whole links, transmitter, receiver, plus the optical cable or something like that.
only a few bucks per axis.
Yeah, shouldn't be more.
Uh huh. What kind of a receiver is it? Just a basically a light, just a little solar cell, little
No,
diode.
like you get purposely built receivers for this already.
Yeah, and those are
Stuff.
diodes, photodiodes, typically, or what are they?
Well, yeah, like in one package you've got either laser or an LED. Not sure what's actually inside the package. And the other is some kind of a photodiode.
Okay.
But you buy this packages sealed with optical connectors on them already. So
Yeah. Okay. Great. And those are like a few bucks.
yeah, like it's less than $1 for each normally,
Okay.
and plus a cable, so that's a few bucks all in total.
Yeah. Excellent. Excellent. Okay, so the only other issue on a torch table is the concerns for when you have the if you're doing piercing and the big volcano of molten stuff comes on a pierce event. What are your thoughts on so if you have the little belts which are pretty much
Yeah,
plastic, some kind of a composite plastic or a
we are
rubber?
considering, putting something like, the dog collar you put around when he
Yeah,
has an operation or something like that.
yeah.
Just that conical shape, just put that around the head and don't worry about it.
Um, okay, something to that effect. But yeah, that's actually a big issue that to have a nice working table, we got to make sure that those sparks. I mean, sometimes, so if a spark lands on your belt, you can fry it. You know.
Yeah, so that's why, just having a shield around the head and just not worrying about it.
Mm-hmm. Mm-hmm. Okay, that's definitely on your radar as a significant issue, right?
Yeah, yeah.
Okay.
So we'll see if we can work it out so it's mounted around the head. That would be perfect.
Yeah.
But otherwise, we need to figure something else out.
Excellent. Okay. That solves that's my main question. The main question for me is can we actually use this torch table scaled to about the 5 by 10 foot cutting size, which is the size of the sheets for the hopper for the thin sheet metal for the brick press. We need to have it 5 by 10 feet.
Should be
So
no problem.
okay, excellent. But you guys are testing on a test models that you are doing. You are testing it up to what scale?
We're
Just
doing
like.
now 1 by 1 meter.
Hmm. Are you guys gonna do a bigger prototype for yourselves, or that's where you're gonna leave
Um,
it for now?
we'll actually see. Uh, we probably will do a bigger one later on, but at the moment we don't have that big stuff to cut, so maybe not.
Okay.
But increasing this is literally just putting in longer tubes at some point,
Yeah,
which
but definitely.
takes maybe an hour.
Yeah, I mean definitely, and we want to make sure that there's not the sag or anything like that. Any issues we don't expect upon scaling, because that you always have to
Yeah,
test.
there will be no sag. We tried running the machine with a guy standing on the head, and there was no problem.
Okay. Did the machine actually was it able to move the person?
Yeah, with this tiny GT2 belt.
The tiny belts were able to move a person?
Yeah,
Oh wow. Do you have that videotaped? That would be a good.
I do. I do somewhere. Just
Oh
randomly.
man, put that on the web. That's spectacular.
It's not a good video because there's more of a joke, but still.
No, I mean that's perfect entertainment for the masses that are following this.
Here's the link. Got the
Oh
video.
wow. Yeah, hold on, I'm looking at it. Slow connection, let's see. Oh wow. Oh, that's amazing. Holy cow, that little belt does that?
Yeah.
How can that do that? What's the belt rated for? I mean,
Who knows? It's a Chinese belt with the
wow.
most specs on it.
I mean, like assuming that the weight is perfectly on it, then it's just the friction of the bearings. But man, that is pretty impressive still, right? I mean, you're probably talking about maybe like, I don't
Yeah,
know,
for
like
plastic
30.
cutting, this is perfect.
Yeah, I mean, if all the weight is vertically down, just the friction, I mean, the friction might be like, I don't know, like 10, 20 kilos maybe, possibly.
Yeah.
10 kilos maybe. That's
So
good.
if you think of it, this weight vertically is then, well, yeah, it's about 10 kilos per bearing easily.
Yeah, no, that's pretty interesting. Do you have a
We
link?
ran
Can you
tests
send
this.
me? Can you send a link to the actual belt? I just want to take a look at its
It's
specs.
just a GT2 belt. Like, I don't know. I linked you the blog
GT2.
post about this where you have some quick tests. for like positioning, acceleration, and stuff like that. Have a look at that and comment on it if you want to.
Yeah.
Or maybe you have done that last time. Not sure about it.
Hello, welcome. Yes, I'm the speaker, so I was going to kick.
That's okay. Is that the one before, or that's a new post? That's
Here's the
29
link to the
April.
belt.
Mm-hmm. 6 mm width, 1/4 inch belt. Huh.
Yeah, don't get much
Huh.
with it. But,
Wow, that's.
let's see. Maybe if Adam
Did
gives us some values, no.
when you did this with that belt, did the belt have any damage on it?
No, not at all.
Okay. Yeah. That's pretty good. Can you still hear me there? Can you still hear me?
But
Yeah, sorry there.
yeah,
Cut out.
internet died on me.
Okay. Yeah, no, that's great. No damage on the belt. What'd you say after that? Um,
Yeah, no
Hello,
idea
welcome.
what the
Yes, I'm the speaker, so
like what this is rated for, but just trying to find the information now. It's GT2 timing belt. It says braking strength of the belt is, let's see, 86 newtons per 1 millimeter, whatever that's supposed to mean.
86 newtons per millimeter. Well, I don't understand that. Yeah. Per
Anyway,
millimeter of belt thickness. Newtons is a force.
per belt width, I would say.
So 86
So
newtons per 1 millimeter of belt width.
yeah. So that's 6 times. Yeah, so that's about 500 newtons
So like
for 6 millimeter belt.
500 newtons is like the weight of 50 kilograms.
Yep.
Wow. Okay. Yeah, that's about right. Excellent. Okay. Yeah. Anything else on the torch table? That's great progress. Looks very positive. I think the optics, if you can get it to work, that would be great. But before that, you're just doing wired connections.
Yeah.
And that prototype, what's your schedule currently on? What's your goal for?
Well, we're doing that stage now, so hopefully next week we can start cutting and testing with it. when we get the plasma cutter sorted.
And the Z stage is you got that ordered already?
No, we're just building it right now.
You're
Let's
building
see.
that, but as far as the controller itself, you're gonna test it prior to the controller first,
Yeah,
or?
we're going to drive directly that from the controller, and then we'll get the plasma, measurement torch height controller and wire that in as well.
Uh-huh. So that the torch controller, you're getting to ready to order that like in the next few days?
Yeah, tomorrow I think.
Okay. Okay. Great. And that should arrive like within a few days to you, and then after the.
Yeah.
Okay.
So next week we need to go to the reseller of this plasma cutters, do tests with different ones and stuff like that, to actually find what different plasma cutting.
Uh-huh. Okay. Very nice. The Z stage, can you hear me?
Nope.
Can you hear me now?
Oh yeah. Now we're back.
Let's see, the Z stage, some of the design specifications for that are, so it's going to be metal in a final version. This is prototype, or?
Yeah, this is just a prototype which we can build with CNC and plasma cutter, the CNC and laser cutter we have at hand.
So basically a strapping machine?
Yeah, for now it's just made out of whatever we can make it out, and later on we'll make it out of metal.
Okay. That sounds good.
Yeah, and this is pretty much reusing parts from a 3D printer for that Z stage.
Are you looking, I mean, when you look at, I see your linear bearings there. I mean, is that the kind of bearing you're going to use in the final, or do you know?
Probably. Like, if this works, why not?
Yeah. Excellent.
These are very low cost ones, so
How much are those linear bearings there?
less than $1.
And the shafts are what, like 8 millimeters?
12.
12 millimeter? Okay.
Yeah, but it could easily do 8. Like, doesn't make much difference.
Okay. Very nice.
And just an M8 threaded rod for the drive of it.
Mm-hmm.
Or actually M6. Just using pieces that are lying around, more or less.
Yeah.
Yeah, so that's it for the plasma cutter.
Okay. When are you looking at the holding of the torch kind of cantilevered like close to the verticals, or like how far away? Like 10 centimeters away from the vertical posts, or do you know?
Yeah, as close as possible we get to it. Actually, if you open the presentation, so the Google presentation we have on the torch table, we added details there. Let me just find the link for it. Okay. Do you have the link, or do you need it?
Send it if you got it. Let's see if I can find it faster.
I found it already.
And a Dropbox link. That's the same one.
Oh, copy it. Okay. Here we go. Just look at slides 12 and 13.
Oh yeah.
Yeah,
Okay.
if you see the slide 12 is what are like general solutions out there, which is fine if you do aluminum and high strength and stuff like that. We opted for the version where we put everything as close as possible to the axis, so there's as little torque as possible on it.
Mm-hmm. The picture that you inserted there, that's just from some other machine.
Yeah.
Mm-hmm.
Yeah, so our solution is just putting it as close to it as possible.
Yeah.
Yeah. And bearings are stationary and the actual axis moves up and down.
Let's see. I'm looking at page 13. So how is that? Let's see. So you've got
The
the
motor
bottom.
moves up and down with the threaded rod.
The what moves up and down?
Motor and the assembly that's on the linear rods moves up and down. So see, bearings are statically mounted
Yeah.
to
I see. Very
the
nice.
trolley,
That's
and
actually,
then it just moves up and down.
yeah, pretty good. Yeah. That's wow. Uh, oh man, I like it. I've never seen anything like it. I
It's just making stuff simpler, much
wow.
simpler than we've seen.
Oh man, this is getting good. Yeah. No, I think you guys are really nailing the simplicity aspects.
Cool, thanks. Needs to be simpler as well.
Oh man.
That's at the moment.
Yeah. So if you compare it to existing systems, um, an existing system typically has some weird slides that are complicated. Here you're just using the sleeve bearings, which are, I mean, that's absolutely as simple as you can get, and just the bottom platform moves up
Yeah.
and down. I like it. Oh man, that's good. I mean, you can move that. If that's the case, then the platform, the torch can be really close to the as close to that threaded rod as possible.
Yeah, just like
And you don't
two
get
centimeters away from it.
spatter issues because all the rod, the drive element is hidden by that platform itself. So you can,
Yeah.
yeah, that's really nice.
And the nicest
Yeah.
part is you can put as long threaded rod and as long linear, rails as possible.
Huh.
Meaning that you can very easily vary the length or height of the axis. So if you were to use this as a 3D printer, you just make this half a meter long, and you can do stuff.
Yeah. 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 No, I really like it. That's great. Yeah. I like the modularity, adaptability. That's right on. Love it.
Perfect.
Yeah.
Yeah. So
I'll build that any day. That's my style.
all right.
Uh-huh.
Perfect.
Yeah.
Perfect. Cool. Yeah. So that's it for this week, more or less.
Okay.
From this. How are you getting on with the brick press?
Brick press. Okay, brick press. So no, we don't have news on a brick press. The concept here is that as we get, so we're getting Yorick to help us on a aquaponic greenhouse structure to help teach us on. We're gonna do it in FreeCAD and Blender. So we're
Okay.
gonna generate a tutorial on FreeCAD and Blender as a result, and we're hoping that as we don't have anybody to do the brick press right now, but
Okay.
as we educate our people and put on training courses. So actually, we're gonna put a first webinar for basically for OSC ambassadors like next week, about a week from now. So
Okay.
we're gonna start educating people so that eventually we can get a work team doing the brick press in open software.
Okay.
How about you guys? You guys want to do any redesign of it for what we talked about, or?
If we get project funding for what we're trying to do in Africa, then yes.
Okay.
Otherwise, we need to do other work.
Project funding through that grant that we were talking about. That thing.
Yes. Yeah.
Mm-hmm.
So trying to see what kind of funding they will come up with for it. If they manage to do it, then we are happy to go ahead with it.
Okay.
Yeah, the question. Oh, yeah. Did you manage to check out Onshape?
No, I didn't. I didn't really look at it. I didn't get
Okay.
a chance. But
I would still argue that might be better than FreeCAD.
yeah.
So do consider it before you go writing all the tutorials for that stuff.
Okay. Okay. can consider looking into that.
Yeah, because it's also collaborative, so you can actually,
Yeah.
as a community, you can do stuff.
Yeah, I'll take a look at that. We want to use all the different tools that are available, especially if it's easily portable. Yeah.
Yeah. So
Okay.
from my perspective, that's second best bet to SolidWorks, which is expensive.
Yeah. Yeah.
Um,
And the Onshape is free for open projects?
well, it's not open source, but it's free for use.
What's their business model? They charge regular customers and it's free for open source?
They charge for closed files.
Okay.
So as long as you have open files, it's fine.
Okay.
But you don't care, so.
Yep.
Um, yeah, question is, so BrickPress is using PowerCube, right?
Yeah. Yep.
Okay. Is PowerCube Imperial metric or this is universal somehow?
No, it's the same materials. All Imperial that needs to be converted. So right now we're finishing up the redesign. Like there's a few minor simplifications or decent simplifications that we did. We're running the workshop on July 10. The finalized file should be around in like a week or so.
Okay.
Maybe by next Sunday we'll have the finalized file. It's all in SketchUp. There's very good developments on the power. We're looking at a gasifier, and it looks very feasible. So we've got a guy that's working with us on that, and we're looking at an 8-inch by 36 by 36-inch pancake that's slapped onto the front of the power cube for a four gasoline gallon equivalent of fueling using charcoal. So it's looking really positive, and the form factor makes it practical so that we can actually use it not experimentally but for real. So,
Perfect.
so we're looking at that's going to be a workshop that we're holding here on July 16, 17. Looks like 15, 16, 17. So at that time, we're going to see how practical that is. Yeah,
Cool.
and it should be.
Cool.
I mean, it's really good because there's a lot of people doing this kind of work. It's low hanging fruit for practical purposes. It appears so. So
Perfect.
we'll see on that.
Okay. Yeah, so at the moment, this is not something we can replicate straightforwardly here. PowerCube,
For
BrickPress,
reason-
and all that without redesigning the metric.
Yeah, you got to redesign it for metric.
Okay.
There's the Indian guys that we should ask them. The guys who are doing the build, who've done a replication in India. I think they I think they might have converted there to metric. We should ask them for their files. I didn't really follow up with them, but they're building. I mean, they did build an older version. I think they actually used the well. I think what they did is they used the old blueprints. So I
Okay.
guess that doesn't help us.
Okay. Cool.
Okay.
What else? We have 3D printer.
3D printer.
Well, yeah, we're starting next week with it.
Okay.
So, not much news unless you got some points on our previous week's conversation about controllers and that.
No, I think that's good, and we'll just roll with it, and I'll write an agreement between us. I'll get that to you like by the end of the week or something.
Perfect.
Mhm.
Yeah, so we should go like for very low cost controller and a decent controller. So
Yeah.
we gotta decide whichever way you want to go. So, and we see what savings we get actually with the end design.
Yep. So we can basically check in on that as that's going, just like we're checking on a torch table and all that.
Yeah, we'll start a similar file for the 3D printer and document and stuff.
Mhm.
Same.
Excellent.
Yeah, so that's pretty much it. What I had in mind for this week.
I think that's it for me. Let's see anything else. I think that's it. Okay, so let's
maybe
do.
on the aquaponics, just a quick update. How are you guys getting on?
It's good right now. We're working on getting. Okay, so the workshop is currently being planned for the end of July
Okay.
with the fully open source files. Right now, we're working on getting some subject matter expert to help us be an instructor on that. We're looking at Mark McMurtry, who's one of the seminal He's like the inventor of that back then in the 80s. We're gonna
Okay.
see if we could get him or somebody else to help us run it. Otherwise, we'll um, yeah. I mean, we want to find some. We're looking for that person right now. So, but that's going on a schedule. It's gonna be for end of July for the build.
Okay.
Mm-hmm.
Cool. Yeah, I'm
Yeah.
in touch with Paolo in UK.
Yep.
So we're trying to figure out the stuff we can do with UCL, for example.
UCL,
Yeah, in London, University College London, in
University
the
College
development.
London.
So they're pretty much concerned with sensors right now. So we're trying to figure out if we can get the sensors developed somehow.
Yeah, and
Collaboration
they're all
things.
on board on open source.
Yeah, all clear on all
Mhm.
fronts. So
Okay.
everything we were saying about educating Arena and all that stuff, everything is open source compliant.
OSHA compliant.
Yeah.
Okay. And that's written clearly in their funding documents, or
Yeah, it's not as far as the funding documents, but I wrote design principles which pretty much state this. So
does everyone have buy-in?
yes, yeah.
Okay, that's good.
So there are no concerns on that front in terms of collaboration, whatever comes up.
Okay,
Cool, that's it.
excellent. Okay, so we'll talk
Alright.
same time next time.
Um, yes. Can you do maybe Thursdays?
Thursdays. Okay.
Well, the same time.
Okay, Thursday works better for you.
Yeah, I've got some other meetings, so I'm trying to congest all the meetings in one day of the week to get more stuff done.
Yeah. Yep. Okay, let's do that
Um,
Thursday.
Cool. So, what time Thursday?
Yeah, can we do the same time? So noon time for us, and your time would be
Yeah, my
7
time
p.m.
is 7 in the evening.
Yep.
Cool.
Okay.
All
Great.
good. Talk to you next week.
Okay. Talk to you next week. Thanks a
Cool.
lot.
Bye.
Bye bye.